Most people have joined, so we can get started. Welcome back to our second class. Last week, we pretty much just did setup. I talked a little bit like introduction of what is Java, and we played around with like one program in Eclipse. We didn't really get to that much, but hopefully today will be a lot different. We're gonna get into the specialties about Java. We're also gonna cover a little bit of programming knowledge that is kind of also shared between languages. So if you have, I know a lot of people have Python experience, that part hopefully will make sense, and we'll see how it applies specifically to Java as well. I know we have a new student today. Welcome, Owen. I want to make sure that everyone can get Eclipse running. So all of you, if you could just start up Eclipse right now, because I know it takes a little bit of time to get running. And if anyone has any issues getting it started, please let me know, because we will be using it in today's class and also all the classes after this. And so let me share my screen. And so Eclipse, okay, I have a donate screen, which is weird, but just get rid of that. And you'll probably, once you get Eclipse running, you should see something maybe like this. For me, it opened up the last program that I was working on, which is just the really demo program that we did last week. If it doesn't show up for you, it doesn't matter, because we're going to be working on a different file. So I see chats. Lucas asks, are there specific styling requirements like in Python? So one of the first things that we are actually going to go over today are kind of what matters and what doesn't matter in Java. And I might have mentioned it a little bit last week, but we're going to, that'll be one of the first things that we talk about. Good question, though. One really quick thing, I was assuming you were talking about like styling or rules that like are mandatory, as in like, if you don't have this, your program's not going to work. If you're talking about like general styles, like do you put spaces before and after equal signs, things like that, it works either way. Some people have preferences. That sort of thing is completely up to you. And actually in Eclipse, there is something, I believe is one of these. There's a lot of things here. Yeah. So if you highlight all your code and go into the top tab source, you can format. And this runs like a set of auto-generated built-in rules, and it will format your code for you. And so to like show that off, Eclipse prefers that you do have spaces between equal signs. But if you code without them and then select everything, and then source format, you'll notice that after I do that, it puts the spaces in. And similarly, like with tabs, we'll see that tabs don't matter in Eclipse, but obviously this doesn't look good. And so an easy way to fix it is to go source format, and it will nicely format everything for you. This is probably more relevant in larger files. Is there a Google Classroom? Yes, there is a Google Classroom. I'll make sure to go over that at the end of class, since it's not super important right now. There's nothing on there that you need for the class right now. But I will make sure that I will show it and show the code to get in. All right, so I'm assuming that everyone has Eclipse started up at this time. If I just want to ask them, does anyone have any issues opening up Eclipse? If you do, feel free to unmute or put a message in the chat and we can debug together. Don't see any questions, don't see any reactions on Zoom. So just a recap of what we did in last week, we created something called a project. And so on the left is our package explorer, where we can see all the different projects that we have on our computer, or specifically in our workspace. And so I have several projects you probably only have one, which is completely fine. We're only going to be working with one, really. So this is the project I made last week, AOE Summer 2022. And I can open it up and I can see the stuff inside of it. And specifically, there's a folder called source. There's something called the default package. And inside the default package, I have my hello world.java. This is what I made last week. And in general, this is the structure. You have a project. Inside the project, you have the source folder. And inside the source folder, you have all the code that you wrote for this project. You might have more nestings for more complicated projects, but in our case, we're just going to put everything inside the source folder. And we noticed that if you want to create a new file, which I'm going to do right now, since I want to make a blank file from this, one thing you can do is you can right-click here, and right-click sometimes takes a little bit of time. You can do new, and you're not going to see any Java file here, but we said you want to create something called a Java class. So it's right here. There's a green C. It's a little bit small, but click class. And then you can see the settings. So one thing, you don't always have to pay attention to it, but the first box tells you where it's going to place it. And you can see it puts it into our project /source. So our source folder. And that's exactly where we want it. The thing that you have to fill out is the name of the class. So today, I'm just going to call it class 2, since today's our second class. You can leave the rest of it alone, except it will be more convenient if you check this, create the public static void main string array args option here. Just like before, you just click finish, takes a little bit of time. And then all of a sudden on our left, you can see this class file now shows up inside our source folder, and it should automatically open up in the middle of our screen with our new class. And if you selected the checkbox that said generate the public static void main stub, you'll see it here. And this is something we're going to see. This is called a comment. This is not part of the code. It's just for documentation, just for us to read, but it's not actually executed or looked at by the computer, and says this is the auto-generated method stub. So I want to make sure everyone has been following along. We have a new class, and this is where we're going to put all the code for today's examples and walkthroughs. So going back to the slides really quick, we see, if I can step through them, this is what Eclipse looks like, and the Java class. So a small note, Java classes have a name, which is what we filled out when what we told Eclipse when we were filling out that form to make the class. And the checkbox that I had you click creates something called the main method. So you might have heard the term method before in the context of programming. In Python, there's methods. They also call them functions. And in a lot of languages, it's also called functions. But all you need to know is that that special checkbox that we create, what it auto-generates is called the main method. And that's what's run when we run our code. So whatever's inside of that main method is what's executed. If you put code outside of it, it's not going to be executed. It's kind of a lie, but for now, you can think of it like that. So make sure all your code is inside the main method. On the slide, it notes that not every class requires a main method. And you might be a little bit confused because I just said, well, only the code inside the main method is executed. So why would you not have a main method? What's the point of that? Well, you might have Java classes that aren't meant to be run directly. Instead, they're more like helper classes, or they define some sort of data structure. And instead of being run directly, other classes will use that and do whatever they need with it. So you can have classes that are just meant as helpers that aren't run directly, and instead some other class which has a main method will call stuff inside that function and use it. And we're going to see how to do that later on. But for now, we want to pretty much run everything. So pretty much all our classes for most of this class are going to have a main method, and we're going to put all our code in the main method. I just want to show that it doesn't have to be the case, though. There's some links there, but they're not really important right now. So for styling requirements, as Lucas asked, some basics. Case is sensitive in Java, and it's pretty much the same in most languages. So if you have some sort of name, make sure you spell it exactly the same with the same capitalization everywhere that you want to reference it. If you change the capitalization, the Java compiler, what runs it, is just gonna think they're two different things. Something that is specific to Java that is not the same as Python is that statements have to end with a semicolon. And I kind of talked about this last class, but it might seem annoying at first when you're programming Java, but you get used to it. And luckily, Eclipse, if you do something that doesn't have a semicolon, you don't have to type this on your computer. I'm just going to demo. If you don't have a semicolon, you're going to see errors on the right where it is underlined. And also next to the line numbers, you're going to see red X's saying, hey, you have a problem. And if you hover over them, they're going to tell you, hey, you're missing a semicolon. Right? So if I hover over it, you see a tip shows up. It says syntax error, insert semicolon. And a note is, you'll notice it said syntax error. Syntax is just a fancy word for styling, formatting, whatever you want to call it. So a syntax error is an error where your code just doesn't look right. You're missing characters, or you're doing something that doesn't really make sense. That's what a syntax error is called. It can't understand your code. There's something called type sensitivity. So you might have heard of different data types, such as ints for integers, or doubles, or floats, or characters, or strings. Those are very common data types. We're going to get into it later, but in Java, types are sensitive. So if some variable is an integer type, which means it stores numbers, you can't store anything else into that variable. You can't change the type later on. Once you say something is a type, then it has to say that type, and it can't be any other. And so this is maybe different than Python, and I'm always going to reference Python because I know a lot of people have a background in that. In Python, types are not sensitive. So if you have like a variable x that stores the number 5, the next line you could say x equals the string hello, right? In Python, you can do that. In Java, you're not allowed to. You have to make sure everything is the same type, or the same variable is the same type everywhere. The last thing is variables must be declared, and I'm going to show you what that means in a little bit. Some other things, really basics, comments and code blocks. So we already saw one example of comments in our code, and that's from this auto-generated thing. So if you notice, there's these 2 forward slashes. 2 forward slashes means whatever else is on this line after the slashes is a comment. And in Eclipse, you can see it's a little bit hard, but the text is green compared to like the black or blue text here. So any green text means it's commented out. It's not going to be run. And this is called inline comments because you can put them in the line directly. So, right. So I can have code here, and then I can have a comment at the later part of the line, and everything else after won't be run. And this is red, but this isn't really an error. If I hover over it, it's saying, for some reason, it doesn't recognize this as a word. So Eclipse is kind of like Microsoft Word. It'll tell you if things are misspelled. But in this case, it's acting up a little bit weirdly. If you want multi-line comments, so you want to comment out maybe a whole chunk of code, then we have these special symbols. Instead of 2 slashes, it's a slash and a star. to start the multi-line comment, and then the reverse to end it, right? So for example, if I want to comment out the entire file, at the beginning, I just put /star, and at the end, I do */. So /star to start, and then the reverse to stop it. And you can see now the whole program is in green, and that means the whole program is commented out. And comments are just really useful for programmers to put notes or messages in the code so that either you or someone else later on can understand what's going on. Because code is not always the most readable, and sometimes we come back after a long time and we're like, what did we do here? And so comments are very useful. And I'll be putting comments in my demo code just to note what's going on when we're learning new things. So I want to take a moment to pause. Does anyone have any questions about these kind of styling things? I guess I didn't talk about code blocks, but code blocks, they're just denoted by the curly braces. So you can see this is a code block. It starts here, ends here. And then this is another code block. Starts here, ends there. And basically, just like the name suggests, it blocks a section of code together. So all this code belongs into the same block, everything inside these curly braces. And basically, in this case, everything inside of these curly braces belongs to the main method. This is what this is called. And everything here belongs to the class. And you can see we can have nest blocks, right? Inside this block, which is all the code for the class, we have the main method. And in the main method, we have a block for everything that goes inside of it. So now I want to take a moment, make sure we're not going too fast. Take a moment to pause. So case sensitivity, type sensitivity, semicolons. The last thing we're going to talk about later, and comments and code blocks. I do want to kind of gauge the class. Does anyone think I'm maybe talking too fast? You can't follow along. I want to make sure we're going at a good pace for everyone. And every now and then I will try to take a pause and make sure everyone's following along. All right. All right. So I don't see anything. So I'm going to move on to the next slide, which is talking about variables and data types a little bit more in depth. So you may or may not have worked with variables before, but I like to think of variables as like a box, and you can put things inside the box and it stores them. So specifically, the slide says a variable is a named unit of data and may be assigned a value. The value may be modified and the name does not change. Some variables are mutable, some are immutable. And we're going to talk about the difference later on, but it deals with whether or not they can be changed. Also, specific to Java somewhat, is that a variable has a data type, kind of a category of data it holds, and it can only hold data of that type. You can't use a variable of one type to hold data of a different one. And we're going to see all the different data types soon enough. So we can look at examples of variables. So each of these lines here on the screen declares a variable. And so you can see the pattern really quickly, hopefully. The first thing on the line is the type of the variable. And so the first one is called something called a Boolean. The second thing is something called a char. third a byte, the fourth a short, and the fifth an int. So the first thing is the type. The second thing is the name of the variable. And then we have an equal sign. And then we have a value. And of course, we have a semicolon at the end of it. So breaking this down, let's just look at the first line really quick. What this is saying is I'm going to make a variable. The variable's name is called result. The type of this variable is a Boolean. And I'm going to set it equal to true. Right? So that it basically tells us three things: what the name of it, the type of it, and what it holds. Lucas says, does it have to have a capital T? So that's a good question. From that question, I assume you're familiar with Python, where true has a capital T. In Java, true false does not use capitals, and it's case sensitive. So you have to use a lowercase t and a lowercase f for true and false. And I'm going to show this in Eclipse, and we're going to see it's actually Eclipse is something very helpful to keep us remembering this. So if I just type it out, and I want everyone to follow along if they can, I'm going to say Boolean, and then some name. In the slides was result, and then equals and true. And you'll notice that what Eclipse does is something called syntax coloring, syntax highlighting. Basically, there's things called keywords. Basically, they're just special things in Java. They mean something special, such as Boolean and true. And you can see that these keywords are bolded and a different color. They're kind of reddish purple. And this is what we want to see. And the result is not really colored differently, although I don't think it's black. I think it's like some sort of orangish color, maybe. And if we just take this as an example and we use a capital T, you can see now that something is wrong. You can see that the coloring went away, the bolding went away. And that's because capital T true is different from lowercase t true. Lowercase t true is a keyword. It's built into Java. It means something special. It's the Boolean false. Capital T true is nothing. It doesn't exist. And if we hover over the error, it actually says, hey, true cannot be resolved to a variable. Like I can't store this thing into your variable result because I don't know what this thing is. And it even tells you some potential fixes. You can create basically a variable for this. And so like, for example, if I just click the second solution, you can see it just creates some Boolean and then it uses that here. But we don't really want this. We just want lowercase t true. And so this is called declaring a variable. And on a previous slide, we said all variables must be declared. Specifically, it's this part. This is the variable declaration. This part is called the variable assignment and doesn't actually have to be here on this line. So if we take, for example, then this one, I'm gonna put it in chat and paste it into my Eclipse. I'm gonna delete the equals C thing. And this is fine. So I'm declaring a variable. I'm saying, hey, I'm gonna create a variable. The name is called capital C. It holds a character and that's it. Right? I didn't give it a value. It has no value. If we think about it as a box again, it's an empty box. There's nothing inside of it. And this is fine. So this is called like an uninitialized variable. It has no value yet, but it has been declared. Like I'm assumedly going to use this in the future. It doesn't have a value yet, but I can give a value later on. So later on, I can say, hey, capital C should be equal to a capital C, right? And this is fine. And you'll notice this line and this line is kind of different. really quickly, can someone either unmute or put into chat, why are these two lines different? Besides that one is dealing with Booleans and another one is dealing with characters. That's not what I'm looking for. Something else. And yeah, Lucas says there's no declaration of what data type it is. And that's correct. So like here, we're saying result is a Boolean. Here, we're not saying anything about capital C. But notice Eclipse is not complaining. Eclipse is perfectly happy with this. And does anyone want to maybe guess why this is the case? Why is this fine? Why is this like normal code? Why isn't there an error? I said all variables must be declared, but here we're not giving a data type to this variable. Yep. Thank you, Lucas. So the reason why this one is fine is because we already declare the variable up here on this line. And variables only need to be declared once. In fact, they can only be declared once. If I try to put the character here, it will actually start complaining. And if we hover over the red, you can see that the complaint it has is that, hey, you have a duplicate variable, right? You declared a variable here called capital C, and now it's thinking that you're redeclaring it, which is not allowed. And Lucas asks a good question. What if I tried to say it was an integer after already saying it's a character? So if we try that, or let's just use Boolean since we use Boolean above. So the first one, if we hover over this one, we'll see, again, duplicate local variable, capital C. So this is like a reused error. Basically, in general, if you ever try to redeclare a variable, it will just say it's a duplicate and won't allow it. So here you already declared up here. You're trying to redeclare it, which is not allowed. And then the other error that Eclipse says is that type mismatch cannot convert from character to Boolean. And so this is very important. This is again talking about type sensitivity. On the left-hand side, Eclipse is kind of like, okay, I know there's an error here, but let's assume there wasn't an error. For example, what if I change this name to an X and I no longer have a duplicate variable? I'm assuming the left hand works. The left hand, what is that? It's a Boolean. But on the right-hand side, what do I have? I don't have a Boolean, I have a character. And then what it's saying is that, hey, there's a type mismatch, Booleans and chars, and specifically, I cannot convert one to the other. But this is a kind of a sneak peek. Some things can be converted because some types are very similar to others. And I'm gonna have a big table of some of the basic types, and we're gonna see which ones can be converted. But basically, the two errors: one, can't redeclare a variable, and two, it's the wrong type. If you could declare it, it still wouldn't work because you have a Boolean here and you have a character there. One quick note, if you're familiar with Python, you'll notice that in Python, you can use single quotes or double quotes. In Java, they mean different things. So for characters have to be in single quotes. Strings, on the other hand, are in double quotes. And they're specific to each other. So you can't use them interchangeably. You have to know, what am I doing? Am I using a character or am I using a string? And depending on that, you either use single quotes or double quotes. And I like to remember it because characters are smaller than strings. So they use single quotes, which is kind of like smaller than double quotes. So back to here, we have bytes, shorts, ints, and we're gonna go over the different types later on. But before we do, just recap, variables must be declared before using them. And so that's basically saying what type it is. They must have a type. The variables can only store a certain type of data. Variables cannot be redefined, which is what we saw just now, the duplicate local variable error. That's when you try to redefine it, and it's not allowed. A variable must be unique. And that's kind of the same thing up here. Once you declare a variable x, you can't redeclare it. You can only have one variable x. And you'll notice the slides do have links. So if you want to look at the links later on your own time, they pretty much say the same things I'm doing right now, but maybe goes into more depth if you like. There's a couple slides here on naming conventions. I don't think they're too important right now. I don't want to spend too much time. Basically, you just use your common sense. There are some characters that are not allowed. So most of the special symbols are not allowed, but you can use underscores or dollar signs. You can't start variables with numbers, whatever, but generally, if you don't have a crazy name for a variable, it's probably fine. Any length, uppercase, lowercase are both fine in variable names. One thing I want to make a note of is you cannot use a keyword for a variable name. So for example, this Boolean result here, I can call it Boolean bool. That's perfectly fine because bool and Boolean, they're separate. But we said before, Boolean is a keyword. It's special, has a special meaning. And so you can't call a variable Boolean because it already has a use in Java. You can't kind of declare it to be something else. And if I try to do that, they'll give you an error. And it says syntax error. It's not super clear, but basically this is a keyword. You can't call a variable Boolean. You can't call it char or static or void or any of these. Like anything that's in purple is a keyword. Can't call it that. Anything else though, that's perfectly fine. And one last thing really quickly about names is the convention I'll be using and is very common in Java is something called Camelcase. So if you have a variable that's like multiple words, what you do is you get rid of the spaces because they're not allowed. And the first word is lowercase, but the other words start with a capital letter. So for example, if I want to call this result of computation, it might look something like this. So notice no spaces, and the other words after the first one start with a capital letter. So this is called Camelcase, and that's what I'm going to be using in this class, and it is kind of the standard. Although this is just a stylistic choice, doesn't matter. You can call it whatever you want, and the program will run. But that's just a convention that a lot of people use. All right, so that's variables. There's a big table of keywords. This isn't even all of them, but you don't have to memorize this at all. Basically, just know that there are some words that have special use, and you can't call your variables these things. So any questions about declaring variables, using variables? So PowerPoint slides, I'll be posting them on Classroom. So the slides will be available then. And I'll make sure at the end of class that everyone has access to Classroom. Notice that we declare a variable once, but we can use it as many times as we want. So once we declare a variable result, you can assign it any value that you want as many times as you want. But notice again, you don't redeclare it. Once you declare it once, that's good for the whole program. So the declaration only happens once, but the assignment can happen multiple times. And I want to make a point of this because I think this is one of the things that can be confusing because you'll see one thing here, but then you'll see a different thing here. And I want to make sure people understand the difference between these two lines. This one is a shortcut. This line is the same as, and I'm going to use a comment, Boolean result, and then result equals true. So this one line is kind of a shortcut for these two lines. Declaring the variable and then setting it to a value. In chat, Lucas asks, what if I tried to change the value of a variable after already declaring it as something? So that, I think, maybe I answered it already, but that's perfectly fine. So here is it with the result. I initially declared it as a Boolean that holds true, and then I can change it to false, true, true. So I think a confusion here and something that's my fault is that really the declaration part is more so the left-hand side of it. So the left-hand side is the declaration. And really what the declaration is saying is the name and the type. This stuff over here is something separate. It's the assignment of a value, right? Yeah. And we can shortcut into one line, but it's really kind of two different things. With a char, I can say capital C is a different character, right? And this is complaining because I don't have a semicolon, but once I put that, everything's fine. All right, let's go over these really quick. So data types. Here's a big table of them. I don't want you to look too intimidated because really only a couple of these are interesting. So specifically, maybe I'll highlight them: int, double, Booleans and characters. So everything on this table is something called a primitive data type. And I'm not gonna go into depth of what makes a data type primitive and not primitive. But just like what the name suggests, primitive data types are kind of the most simple kinds of data types. And there's things that apply to primitive data types and things that don't apply to them. But for all intents and purposes, these are kind of your most basic data types, the most common ones that you're gonna see. And really, some of these are similar to others. So really the unique ones are ints, doubles, Booleans, and characters. Why are the numbers so specific? Good question. So when I said there's kind of like duplicates, here's an example. Bytes, shorts, ints, longs, they're all just storing whole numbers. The only difference is the size of them. So for example, bytes are 1 byte, shorts are 2 bytes, ints are 4 bytes, longs are 8 bytes. And I don't know how much people know about how computers work, but everything on your computer is stored in memory in units called bytes. And bytes can even be broken down into something called bits. And that's the zeros and ones that you might hear people talk about. Like your computer thinks in zeros and ones, it stores everything in zeros and ones. Zeros and ones are called bits. Bytes are just a collection of bits. So ints are your bread and butter data type for whole numbers. They're your most common, they're the most used, and they're 4 bytes. What this means is it takes up 4 bytes of memory on your computer. The more space it takes up, the larger range of values it can represent. And that should make sense because, for example, if you only have 1 bit, you can only represent 0 and 1. That's all, because you only have 1 bit. If you have 2 bits, you can represent 4 different values, and so on and so on and so on. So with 4 bytes, this is actually 32 bits, you can store values from roughly -2 trillion to +2 trillion. And longs, on the other hand, are larger for 8 bytes, and they can store much larger ranges of values. On the other end of the scale, you have shorts and bytes. They're smaller. So as a consequence, they can only store smaller ranges of numbers. So a byte can only store -128 to +127. So if you had a number like 200, a byte cannot represent that number. Lucas asks, why don't we just always use long then? Why use ints or shorts or bytes? Why have them at all? And so does anyone want to guess an answer to this? Yeah, Caden gives a great answer. Because it takes up more space. And sometimes space really, really matters. In our programs, probably not really. We're never really going to be constrained with how much space our programs take up, especially because our programs are mostly just going to be like one file with a couple lines of code. It really doesn't matter if you use longs, ints, shorts, or bytes. But if you're working with a really constrained system where you don't have that much space on your computer or whatever is running your program, you might have to actually use these smaller data types if you can. Does too much space generate lag? I would say not really. Like with an asterisk, like it can impact it, but really it's not a big factor. And that's not the main reason to use one over the other. In general, we're just going to use ints everywhere. And that's actually the default. So if you, I'll talk about this more later on, but ints are the default value for whole numbers. It's not a byte, it's not a short, it's not long. Ints are the default. Similarly, floats and doubles are similar to each other, except for the fact that doubles are larger than floats. And floats and doubles store what's called floating point numbers, or more commonly known as decimal values. So if you want to store a value like 1/2, you're going to use a double. The only difference is the size. And for floating point numbers, really the size is more of how precise values can be. And I'm not going to get into it that much, but everything on a computer with decimal values is not always going to be 100% precise, because you can't store a number like 1/3, 0.3 repeating into a computer perfectly, because a computer has limited space. It can't store an infinite number of digits. So at some point, it just has to cut it off and say, okay, this is my best, closest approximation to the value that you give me. For most values, the approximation is like good enough. Like it's going to be different from the real value, like 10 decimal places or 20 decimal places down the line. And for most things, that's perfectly fine. But it can cause issues if you're not careful. And so a fun fact is, if you're working with floats or doubles, a lot of times you don't want to compare them using the equal sign, because of the approximations and small errors, sometimes you'll have two values that are really close to each other, and all intents and purposes, they're essentially the same, but they might differ in maybe the 20th decimal point. And really, we don't care about this. This is just some approximation error, rounding error. And so really, when we're comparing doubles to each other, the better way to do it is to just say, are they within 10 decimal places of each other? Are they close to each other? Instead of, are they exactly the same? Because sometimes rounding errors will catch you. In chat, Lucas asks, what if I was trying to calculate something like large primes where the value will go above the maximum for longs? Good question. There's data types to support that. Specifically, there's something called big int, and that will store any number you can think of. However, that's not a primitive data type, which is what we're focusing on right now. Kind of one thing you can think of it as is a lot of the non-primitive data types kind of are built upon primitive data types. That's not really the best definition, but generally there are other data types. This page does not show all of them. These are just the basic ones, and we're going to see others later on. So answer, there are other data types that you can use to store much, much larger numbers. Finally on this list, Booleans and Chars. We kind of saw this on our example in the code. So Booleans hold true false values. That's it. And so because of that, the size is 1 bit. Although it's an asterisk because some computers will use a whole byte to store a Boolean, just because bytes are typically the smallest units that a computer will work with. So even though it only needs 1 bit, sometimes it'll take up more space. Chars store text data, so a single character of text. You might know something called strings, which is basically just a bunch of chars. A string is not a primitive data type. We're going to see that maybe next class or later on. We're going to see it, but that is not a primitive data type. I want to do something here. So type conversion. So I mentioned that ints and longs we talked about in chat, they're kind of similar to each other. They both store whole numbers. And because they're so similar to each other, Java does allow converting between them. And there's a couple different ways of converting. So what we're going to talk about right now is more of like kind of implicit converting, where we don't have to do a lot of work. And so, for example, you can convert an int into a long data type. Let's see here. So I want to show that off right here. So if I say int x equals 6, right? I create a declare a variable x that stores ints, and I assign the value 6. So great, I have a variable x. Then I want to say long L, right? And I end it off. I declare it, don't give it a value yet. I can say L equals x. And what this does is it takes the variable L and assigns whatever x is to it. And I can do something like system.println. So let me take this code, put it into chat, and I'll just run it. Let's see, and no surprise, it just prints out 6. So you can see I took my int and I stored it into a long, and I print out L. Right. This is perfectly fine because an int is a smaller data type than a long. And so that means I can always convert an int into a long without any issues because longs are just more powerful, strictly more powerful. Anything that an int can store, a long can also store. But the other way around is not the same. You can have longs that represent really big numbers that ints just don't have the ability to store. And because of that, you can't convert the other way. And what I want to show you that is like, if I say long L equals 6, and then I do int x, and then x equals L, and I print out x, you'll notice this code has an error right here. This red underline, type mismatch, cannot convert from long to an int. And that's because I'm trying to assign this value to this variable. This is a long, this is an int, and it can't convert because longs are a bigger data type than ints. So hopefully that made a little bit of sense. Does anyone have any questions about that? Quickly, I'm going to go back to the table. Basically, what I'm saying is you can go up the table without any issues, but you can't go down the table. So longs, you can take an int and put it into a long, but you cannot take a long and put it into an int. It just doesn't fit. Same things with floats and doubles. You can take a float and turn it into a double. However, you cannot turn a double into a float. Even if, in this case, this long is storing the number 6. And definitely you can store 6 into an int. But Eclipse is, you can say dumb. Basically, it doesn't matter what the actual value is. It just says, I can't always do this, so I'm not going to allow you to do it, period. Right? So even technically, I could do this. In this specific case, I can't do it in general, so I'm just not going to allow it. One thing that might blow your mind, though, it's kind of cool in my opinion. So if we start typing out numbers, or actually really quickly, we can see that ints can store up to this number. So if I just take this number, put it into here and get rid of the commas, that's fine. But what if I go to 8? I actually get an underline, which is kind of weird, right? Because we said this is the range for an int, but we're working with a long right here, long L. So longs can store up to like much larger numbers, like this giant number right here. So why is there a problem now? And so whenever you get an issue, whenever you have a problem, you hover over it and it says, the literal that of type int is out of range. And so half of this error should make sense. Well, yeah, that number is too big for an int to store, but where are we dealing with ints, right? We never said ints anywhere. And so this is where, previously I said ints are the default in Java. This is another way we can see that they're the default. Whenever you type a number literal, so whenever you type out a literal number, Java thinks of it as an int. It almost creates an invisible int variable and puts it into that invisible variable. And so what it's doing here is you put a literal number here, you typed out a number, it's trying to put it into an int variable behind the scenes, invisible. We didn't write the code for it, it just tries to do it automatically. And it can't do it because it's out of range for an int. But really this code shouldn't cause a problem because we're storing into a long, right? Longs can handle this. And so what you actually have to do is you put a capital L after the number. And this says, hey, I know ints are the default, but for a second, ignore that. This is actually a long type number. And so this L is saying this is a long. And so now the red line goes away. But note, if I print out the value of L, this capital L doesn't show up because this is not actually part of the number. This is just a special symbol for Java saying, hey, don't use ints here. This is a long value. And actually the same thing applies for floats and doubles. And so let's say here, if I say float f equals 1.5, right? And this double d equals 1.5. If I don't hover over it, we should maybe be able to guess why there's an error here. Both doubles and floats are used to store decimal values. Here I'm trying to store 1.5 into this variable, perfectly fine, does not complain. But when I try to store 1.5 into a float, it starts complaining. Can anyone tell me maybe why this is the case? Great, Caden. Floats are smaller. If we go to the table, floats and doubles, floats are 4 bytes, doubles are 8 bytes. And as we said before, you can convert smaller things into larger, but you can't convert larger things into smaller things. So what's happening here is that doubles are the default in Java. Whenever you type a decimal value, it behind the scenes stores it as a double. So this 1.5 is actually stored as a double behind the scenes. And you can't assign a double value to a float variable because again, doubles are larger. And so it's just like this with the L, you have to put an F for floats. And so this F is not really part of the number. It doesn't have a value. It's basically saying that this is a float. Don't use a double behind the scenes. Does that have to go? No worries. We're about at the end of class. I'm sure the recording will be helpful maybe for the last couple minutes. Yeah. Right. So that's the data types. And I spent a long time on this, even though we might be already familiar to this concept from Python or other languages that we've worked with. Because it's one of the special things about Java. Java cares a lot more about types than Python does. Python actually kind of does all this behind the scenes, but it's behind the scenes. You don't deal with it. When you create variables, they're just variables. They store anything. And Python behind the scenes figures out what all the types are and manages it for you. Java, on the other hand, you're in control. You decide what types variables are. And once you decide, they have to be that type. Why is there an uppercase for long but a lowercase for float? Good question. To be honest, I don't really know the answer myself, but that's just how it is. Really quickly, I'm not sure. All right, actually, this is an example where it's not case sensitive. So you can put L lowercase and F capital case, but I think it's very common to have this as the convention. Specifically, I think for this one, it makes more sense because in a lot of fonts, ones and Ls can look similar to each other. So it's less confusing if you have an L. F's, just a lowercase f. All right. So with the last couple of minutes, I have 4 minutes left. I'll cover some of this in next week's class, but I'm just going to introduce operators really quickly. And the reason I'm going to do it quickly is because I think this is something you should be familiar with, even if you haven't done programming before. But there's a lot of basic operators like plus, minus, star for multiply, and slash for divide. So for example, if I have two ints, int x equals 6, int y equals 2, right? I can do things like x divided by y, x slash y. And if I run this, it's going to take 6 divided by 2 and give you 3. If I do x times y, 6 times 2 is 12, does 12, plus minus, same thing. And so unfortunately, there is no exponential operator like shortcut, but there are ways to do exponents, but for now, we're not going to cover it. There is no operator for exponential. You can't do this, which is the Python way of doing it. You can't do this. This will compile, but this does something that you don't want. Yeah. And so the reason I cover that is because it will be useful for today's homework. And so there's a very, very short homework. And the assignment is to create a simple program to convert from Fahrenheit to Celsius. So the two temperature scales. You might know the formula. There's a very simple formula. It's like from Fahrenheit to Celsius, it's minus 32, and then take that value times 5 divided by 9. I'll give the formula when I post the homework in the classroom. But basically, the assignment is just to write a program that someone can type a Fahrenheit value, and it will convert it to Celsius. And when I say type it and convert it, what I mean is really, your program is going to look something like, I can't spell. I'm going to say F and C. So you're going to need to decide what type it is. You can use ints, but you might want to use a different data type. But it's just going to have, you can type whatever you want here. So maybe my Fahrenheit temperature is 90. And then I have some code to convert, and I get my Celsius degree. And then maybe at the end, I want to print it out. And so here, I don't do any converting. So this is not a working program, but this is what it's going to look like maybe. You have a variable f, you do something, you convert the value into the Celsius temperature, you want to store it into a different variable, and then print it out. So you don't actually have to take user input through any typing in the command. You can just take it from the program itself. So if I change this value to 100, then your program should output a different value. And same if I put in like 50, then it should print out the correct value. So again, this is like a demonstration of what it would look like if you use imagination, but basically you just need to figure out what goes in between here. And what you're going to use is the variables with data types. Be careful about declaring and not redeclaring. And you're going to use your operators, the times, multiply, divide, minus. And hopefully it shouldn't take too long. But if you have any questions, feel free to email me. My email is already posted on Google Classroom, but it's also on the slides right here. If you have any questions about the homework, how to get started, any bugs, feel free to contact me. And last thing, I promised that I would go over Google Classroom. So here we have kind of a really short recap of the first class and also the recording. It's going to be similar for the next couple classes. And here's the access code. It should have been sent out in an email to your parents. But if not, go to Google Classroom, put in that code, or also I can also copy it. So do we just put the answer or do we copy paste the code? Oh, that's a good question. So I would want you to upload your code. And you can do that in a couple of ways. If you're able to, you can find the Java file on your computer and you can paste it into Classroom, or you can just take a screenshot. So in Eclipse, you can just take a screenshot of your code. For example, I'm just going to take a screenshot of this and submit that picture as my submission. I'm fine with both. I just want to see the code and maybe see the output as well, but hopefully you test your program, so hopefully it should work. I just want to make sure everyone is practicing. Really, I'm not grading any of you. I'm not doing that. The purpose of the homework is just for me to make sure everyone is practicing what we just learned and hopefully not forgetting everything between every week, because when we have classes every week and nothing in between, it's really easy to forget everything. And so the homework is just a really short practice to make sure we're kind of reviewing it as we go along. All right, I know I'm 2 minutes over time, but that's all I had for today's class. Thank you for sticking with me. If you have any questions about course logistics or things that we covered, I'll be sticking around now to answer them. If you don't have any questions, that's all I have. Feel free to sign off and I'll see you next week.
Thank you. Bye.
Same time. Yep. Bye.
Thank you. Bye.
Yep, you're welcome. Bye. Right. Bye, Kaden.
Thank you. Bye.